Hello and a very warm welcome. Today I would like to show you an illusion. An illusion? Color is an illusion. There aren't any colors. You don't believe me? Okay, I will try to explain. That what we see as light and colors we see as light. That are electromagnetic waves, exactly like radio waves, but of very higher frequency and a much smaller wavelength. And when we look exactly at the visible area, around about 789 terahertz and up to 483 terahertz, or converted into wavelengths, we can say 380 nanometer to 480 nanometer, about this area. How do we see color? We only see the lightness of a certain area. In our eyes, we have rods and taps. The rods are for seeing black and white. They can't see that good in brightness, but can see better in the dark. The taps are responsible for seeing that what we call color, and we have these in three different types. That means they see a different color and a different frequency. Better. They look a little bit outside of their area. That has to be so. I can show you that in a minute. So on how that works, I'll show you with white light. Because it is not a color, it is a mixture of different frequencies, different wavelengths, different colors, a white picture, which I've drawn myself, no problem. And when I take this white light and press it through a prism, would it through the breakage of the prism be dismantled in a spectrum? And when I look at the spectrum, I can see left starts from the higher frequencies with black, that is ultraviolet, we can't see that. And then we have violet, blue, cyan, magenta, turquoise, and then into the greens. Out of that into the yellow, then orange, red, and then it goes into the infrared. We can't see that either, that's why it's shown in black. The colors, so as I have broken them in the prism, I can put them back together, like with a flash lamp. And as you can see, when they are aligned properly, it gives the colors which we have seen, and in the middle is white. That is by the additive mixture. There are also, as you would say in your printer, the colors cyan, magenta and yellow, or in your inkjet printer we have here, because there are layers which always take a certain proportion of the frequency out, take a color out, at the end of all that is left is black. That is only the theory you have at the end of black cartridge, because you can't get perfect black like that. I have written down the frequencies and the colors and the wavelengths which belong to them, which you can convert with the speed of light. Here we have the maximal from the taps in our eyes, in which area they can see maximal lightness field. The brain calculates from these lightness measurements the color. From experience, what our parents have taught us in the school, from our environment, and then we become this color spectrum. So, and because from one person to another there are little differences, from how you feel or how you are, it is dependent on the light from outside, and so forth. We can't say precise, this is the color, we can maybe compare it. Our eye can compare up to 20 million different shades of color, but really precise it is not. And for this we need measuring instruments, and these instruments are totally incorruptible. They give the exact wavelength of a color or show a mixture. Show, take out and show again, and we need them all there where it depends on color content. I tried myself a color measuring instrument, and color measuring devices, that is a very wide expression. That is a device with which you can see single colors, measure, make a spectrum, It has an incredible number of options. The MK350N, so I've turned it on already, and I could have a look what we have here in the studio for a lighting. It is thought to judge LED light, to measure, and when I just push on here on the measuring key, then you can see we become some displayed. For example, color temperature 2651 Kelvin, CRI, lux, brightness, lamp P is by 613 nanometers, and so forth. That I can see over the spectrum and display it. When I go back here and go to the spectrum, you can see, so is the distribution of the frequencies of the light and the color, or however you want to call it, over the spectrum. It goes from the left from 360 nanometers to here to the right up to 760 nanometers. And you can see exactly there are a few peaks in it. It is distorted here in the studio because we have a lot of lighting. I can also let it be shown in color rooms, for example the CIE 1931. There I can see how it is assessed there, or after the CIE 1976. It looks there like that. All that what I have in here, I can have as a table for a table calculation. And over the USB interface, which I have on this side, transfer to the computer, and I can also transfer it as a BMP picture. And then I have the picture which I have on a display on the computer. I can save up to 2000 measuring values. I also have here a slot for a memory card. Yes, and that's all. Built in as a battery pack, a loading device is naturally supplied, and also a protection bag, which is very stable. The device is small, light, handable. Oh yes, the sensor you can see at the front. There's naturally not a lot to see. So that is, so to say, for really special LED light. Thought for. Not single light diodes, you can measure them as well, no problem, to see in a series if they are in the spectrum and lay on the frequency properly. I've brought with me a small testing device, a LED tester, and I've put 4 different diodes in it, and when I activate it, as you can see here, we have it in then. Naturally it's a bit difficult in the studio, we have a lot of light in here. You have to try very hard to hold both of the devices and at the same time cover it up from the light up there. So now I have recorded it, and you can see very clearly here, left the blue diode is exactly seen and measured. Green and yellow lay pretty close together in the spectrum. That was why they are divided. And then comes the red one. And further to the right, it goes nearly into the infrared. That is the light in here, the room lighting. Now if I also show you white light, white as a color doesn't exist. Let's see if I can dazzle the camera. So, and that's what it looks like. And if I measure that, you will see the spectrum is shown properly. So, in white light, all frequency parts are included. If you have fluorescent tubes, or diodes, or LED lamps, if you see that the most light doesn't go through all frequencies, then you can find it out. Here you can see it and measure it. With this you can see which wavelengths are emitted, and then of course in the industry, production and so forth, be used for quality control and testing. A device which delights me, and it is fun to see things with which the eye doesn't recognize. That we do in our heads, like recognize lightness from different wavelengths, to recognize a color that does this device too, but precise and incorruptible. An unbelievable, precise, dear device, you can see color differences, recognize them, differences that are so fine, I think our eyes would fail brutally. So when we look at it, a hand device is actually for usage with one hand. Here at the back is the trigger with which I start my measurements, and when I have it in my hand and push on it, then I become my display at the front. Here we have an on and off switch naturally, and here under the lid the connection ports for the USB and a charger with which the built-in battery is loaded. You can also use it directly with the charger for permanent measuring. Makes sense because you can attach directly to a computer. Not only is the evaluation software by, but you can also, using this software, the device, you don't need to push the trigger. So now we want to look. I have here different things. When I go here and give samples in, I also have the possibility to go into a menu. There I have different choices I can make. Could, for example, put in communication here, which I would like to show you soon. But first we go back so I can show you how it works. Here at the bottom it is placed on to measure a surface, and not for light directly. And as you can see here, here's the plate where it is put down on, and inside you can find the sensor, which records the spectrum. Then the electronics work. When I put it down on here now and make a picture, you can see that the values change, so it has measured and analyzed. I can also let it be shown over the wavelength as a graph. Now when I go to a different colored piece of paper, then you can see it takes a little while how the curve changes. That means that the color displacement in the material is totally different. The absorption and reflection is different. So now one more time to the next one, and as you can see it changes again. If I now connect the device to the computer like already explained, the installation of the software is easy. It is recognized from Windows. Then you have to go to here at communication, and in this moment it finds itself in communication mode. Then I can carry on with the computer. The software has packed everything onto one screen. Now it's a bit difficult for the camera to see it because it is very small, but I can also at the top in the menu bar choose all the symbols. For example, the black and white balance. I'll show you that in a moment. There's also an accessory which is delivered with it. The curve is shown in the right hand side graph, and naturally I can record at any time a new recording. As done before, simply put it onto a different surface and then once again record. It is the same from the display of the device as on the computer. That means you can use this device anywhere to test and from the PC operate. And I can use the data in a normal form like tabular, calculation and so forth. Endless possibilities, endless, well not really endless, but 7 or 8 color forms, different areas, different standards which you can use, fault tolerance, deviations and so forth. So an absolutely professional device. And because I promised, I just want to show you, with this I can ballast black and white with. The backside is really black so that you can't see anything. So the colorimeter NS800, really the top device you can find at the moment for the normal industrial usage. So now both instruments next to each other, the MK350N. Now I'll show you the transportation case which is delivered with it. Naturally there is the power cable, USB cable, instructions and so forth, everything what you need. Also a cover cap, a device for light measuring, mainly directed to LED lighting. There you can measure the quality, the goodness and the color from such LED lighting bulbs. You can naturally measure everything else, but that is what it is thought for. It is a device which is stood onto a surface for solid materials and surfaces and so forth. It has its own lighting, and that comes also in a stable case with everything what belongs to it, battery, power cable, USB cable, software and so forth. Both are devices of high quality and something like it I haven't had in my hands before. That you can make your own sensors much better, so distinctly better. That what we cannot do, quality control of colors, is with these devices a kid's game. And even though they have so much possibilities and setting options, for the expert no problem, is the operation also a kid's game. I could do it. So the illusion of color I'll take away from you. I'll show you now how the world really is. Bye, until next time.